GIRI is a tool for policymakers and investors to understand potential risks to their country's infrastructure. It can be thought of as an atlas, which directs decision-makers towards investments in resilience. In Bangladesh, for example, GIRI shows that investments in resilience to floods would help to protect essential services. In Chile, meanwhile, GIRI highlights the need for the power sector to be resilient to earthquakes. By indicating risks from natural hazards and climate change to critical infrastructure, GIRI showcases the resilience dividend to be gained by investing today for a more resilient tomorrow.
Andrew Mascri, the discussant for today. Andrew is an urban planner. He holds a doctorate in disaster risk management and a postgraduate degree in geographical information systems. He has worked as the chief of the Disaster Reduction and Recovery Unit at UNDP and has been the coordinator of the United Nations Global Assessment Report on Disaster Risk Reduction, the GIRI report, producing 5 editions of GIRI between 2009 and 2017. He has worked as an advisor to the Council of Ministries of the Government of Peru, the Global Center for Disaster Statistics, the Islamic Development Bank, the Asian Development Bank, amongst others. He was the coordinating lead author for the first edition of ICDRI's biennial report and is an advisor for the second edition. So, Andrew, welcome to the discussion. My first question to you would be to really provide insights into the GIRI model itself. Could you talk about the inner workings of GIRI, specifically how it utilizes probabilistic risk assessment to offer a comprehensive understanding of infrastructure risks spanning across different sectors and hazards?
Thank you very much, Swapnil. Is this working? Yeah. I'm not going to describe the inner workings, but a little bit like the outer workings, because the outer workings is what people will see. They won't see the inner workings. But a few words about GIRI. The first thing is it is completely probabilistic. So those of you familiar with the way the insurance industry and catastrophe modeling companies address risk, this will be extremely familiar to you because we use basically exactly the same conceptual framework and methodology. The difference is GIRI isn't applied to a specific portfolio of assets. It's applied to, all the infrastructure assets of the world. So I think one of the, let's say 3 characteristics of GIRI I'd like to really emphasize to the user. One is that it covers every single country and territory in the world. It's completely global. It doesn't leave out anywhere. The second thing is we've tried to cover systematically all the principal infrastructure sectors. So it has power and energy, telecommunications, water and wastewater, roads and railways, other transport infrastructure, health and education, and actually housing and the rest of the building stock as well, which is important. And we've tried to cover most, not all, of the principal natural hazards out there. So it covers cyclonic wind, storm surge, flood, landslide, earthquake, and tsunami. There are gaps, we can talk about that later on. But I think for the user, it's for the first time ever, we now actually have figures, quantitative figures, dollar values, of the contingent liability that over the years and the decades we've been building infrastructure has become internalized in the world's infrastructure systems. So I'll stop there because I know you have other questions.
Thank you. So you spoke about the GIRI data being a publicly available set of metrics. So your thoughts on how do you envision that GIRI, how could it play a role in influencing policy, investments, and actions of different stakeholder groups who will be users of GIRI? So if you could shed light on that.
Thanks, Swapnil. Yes, I'll refer back to a phrase that Dr. P.K. Mishra used in his introductory speech. He said that if we don't actually strengthen resilience, making new investments is like pouring water into a bamboo basket. You pour the water in and it flows straight out again. And I think what GIRI actually does, it can tell policymakers and planners, if I pour so much water into the basket, this is how much is actually going to flow out, which is really the concept of contingent liability. So if I'm sitting in, let's say the government of Peru, and I want to know what is the contingent liability of my road network to a given hazard, let's say landslides, it can give me that figure. Now, if that figure is, low, it means, future investments, I'll have to probably make some adjustments for resilience, but it's not going to be a huge problem. But if I find out that my contingent liability represents a very high proportion of the asset value or of my expected future investment, it means I'm going to have to look very, very seriously about how I strengthen resilience in that area. So I think it's useful for governments, anyone in charge of public investment in governments or infrastructure planning. It's obviously useful for the private investor as well. We've heard in the last session about, the importance of estimating, risk-adjusted returns, so it can help us do that. I personally, when I've looked at projects funded by some of the multilateral development banks in the past, I've been actually shocked, and this is recent years, of seeing how, risk-adjusted returns do not take into account a lot of these contingent liabilities. So this is so important for us. So, for investors, for governments, and also I think it's, can provide, in a sense, a framework, a language in which we can actually start to compare risk across infrastructure sectors, across countries, and across hazards, and then actually have a dialogue about how to reduce that.
Thank you for that. So, Andrew, if we zoom in a bit and we talk about, the key findings of GIRI, which feature in the report, also about its scale and application, do you have in mind some examples of key findings from GIRI, that provide insights regarding the resilience of infrastructure assets across different territories? If you could focus on some of the LMICs or the SIDS that feature in the report. Yeah.
Well, the report and GIRI itself is full of data, so I'll just highlight a few things. We estimated the total average annual loss, so this is the average loss one can expect over the long term, across all infrastructure sectors in the world, to be around $700 billion. Now, I think that represented, when we looked at it in the report, something like 14% of 2002 global GDP growth. So that in itself is quite a damning statistic, because even with the climate as it is now, infrastructure as it is now, that just shows how much of GDP growth we're losing by not strengthening resilience. When you drill down, you can then see how the problem is actually significantly worse for lower income countries, lower middle income countries, than it is for high income countries. High income countries have the bulk of the exposure, exposed assets, but have far lower risk. Lower income countries have a lesser proportion of the exposed assets, but have higher risk. And you mentioned, SIDS. This is probably the most extreme case, where the relative risk is amongst the highest in the world. We have to look at both the absolute risk, the absolute contingent liability a country has, but also its relative risk in terms of as a proportion of a capital stock in GDP. So the model, very, very clearly indicates groups of countries and specific geographies which need to be looked at with care.
Thank you. One key piece of work as part of the GIRI initiative was the development of the data platform, done, of course, by the consortium, but led by UNEP GRID. A colleague from UNEP GRID, Andrea De Bono, is also here, and he'll be up on stage in a bit demonstrating the platform to you. But Andrew, one last question to you, if you could, explain the process, because it was a complex process, it was a rigorous process to develop this fully operational data platform. How do you think it will empower users to engage with the platform and use the financial risk metric available in its current version?
Well, I mean, the platform's out there. It's completely available. It's completely open. So it's one of the things we wanted to do with this, in a sense, is open the black box. Because a lot of the proprietary models which the insurance industry and others use to estimate risk aren't open to anyone. So I think it's a fantastic opportunity to actually start a debate on risk. I often get asked the question, I mean, are the numbers accurate or not? I mean, they're as accurate as any model is. But I think the objective of the numbers is to actually start a debate about risk. And this is what we really hope happens, risk and resilience. Thank you.
Thank you, Andrew. Since we're running out of time, I will invite Andrea De Bono. Andrea, if you're here, please could you come up on stage? Andrea will be presenting, taking us through a demonstration of the GIRI data platform. He holds a PhD. He joined UNEP GRID in Geneva in 2001 and presently leads the Data and Information Sustainability Unit there. His career began as a GIS analyst and data manager for numerous UN projects addressing topics like urbanization, renewable energy, land management, and disasters. In recent years, his primary focus has shifted to managing platforms for visualizing and distributing environmental data for UNEP and other UN organizations. Over to you, Andrea, and perhaps Andrew and myself can join the audience when and Andrea takes over. Thank you.
Thank you so much. And welcome into a world of data that will arrive after. I take the occasion to say that the platform that I will present you now is also available in the main screen outside the room, so you can play a little bit later if you want. So there are three main sections on the platform, because of course it's a platform to show the data set, but not only. It's very important to put the data in their context. So we have one section is more for map vision, data for hazard and exposure at global scale, visualized under like map with the pixel style. And you have a section more on the risk metrics based on country profile or comparison between the different countries, and is under the view of dynamic dashboards. And the third section, I will start with this one, is the information layer. So it's very, very important to give the information in the context. So we start around three levels. The first one is the general information. So we have a glossary, we have detailed methodology with all the paper that we published. Is more technical paper in order to understand the methodology, the data used, and the next steps, and so and so. And for people who want to go a little bit more further, all the literature behind our studies. This is the first level. The second level is the information by the different topics. So you will see later that we have different subjects. And for each of the subjects, we have a very snapshot, a very short methodology in a nutshell in order to quickly understand what you are speaking for. This is, for example, for the exposure model. This is for the flood hazard. And the third level of information, when you go in deep on the different data set, you can click and you have the access to the classical metadata about what is this indicator, who prepared, and the license. And of course, there are another level that is, if you need more support or a specific question, you can always contact us. So we start with a very, very short tour about the risk matrix. So here is a page. You go in the risk matrix. Here you have a selection of the different topics. Here we can select about if you want to have a country profile or comparison with different country. And here we have the data frame for the interactive visualization. Where you have some control. For example, you can change the country or other kind of selection. So try to answer a questions. For example, we are in we are in the main section, in the introductive section. We focus on the country profile. In this case, we are in the Philippines. The first question: what is the overall average annual losses of the country? You can see there. What are the main hazards and how much they affect the countries? And we can see in this case that there are three main hazards with also the amount of the average annual losses in million. These are earthquake, floods, and tropical cyclone. And the third question: how are the main infrastructure affected? We can see there in this chart that water and wastewater are more affected by earthquake than oil and gas, for example, that are more affected by tropical cyclone. If you want to have some answer concerning how the climate, the different climate scenarios affect our structure, we can focus on this part of the platform, where we see at global, like aggregate level, that the upper boundary is quite important for this country. We are in Nepal for this example, and you have also evaluation of the annual average losses in $1 million. And also, if you go a little bit more in detail by infrastructure, for example, you see that you have two kinds of infrastructure. One is building, and the other is telecommunication, that are more affected by climatic scenario than the others. And if you want to go a little bit more in detail, and so we can choose a specific hazard, you have, again, information about the different infrastructure, and also with more detail for each of the infrastructure. So, for example, for power, we have the transmission, the power production, and so and so. And also, we have more detailed risk matrix for each of the different infrastructure, how you can see in the right screen. Here, for cyclonic example, we are always in Philippines. We have the losses caused by wind and the losses caused by surge. Very fast overview concerning the possibility to make comparison between the countries. So you can choose a region or a continent, and inside this continent you can choose a country that have a similar income as classified, defined by the World Bank, and or you can choose different countries as you want, and see, you can see the different. Your country was always Philippines among the other country. What is what's happening? Let's go to the map viewer, to the geospatial section. So you have basically two panels. One is for choosing the different layers, and the other one is for the visualization. There are three types of data manipulation. So we can go in the first screen. We have a selection by the team of the most significant important layers. We have all the list of the layers. It's around more than 100 now, so a lot of. And this is the third section where you create your workspace with your layer in order to make some specific analysis or share with other people. I have a very short animation. Okay, so you can visualize your layers. We are in Ethiopia, and we choose a flood hazard layers. Some information we can play like in classically platform with some parameters like transparency and so on. We zoom a little bit, and we will also add another layers. For example, this is landslides. Also, we can add the basic information. Now we will fly a little bit. We have a possibility to have a 3D models and zoom a lot. Even if it's not an application for land planning, it's a global application anyway. And after, you can see the legend of the different layer. If you need to have a little bit more in deep, you can create your space of works. So you can choose a layer with free test or using keyword. After this, you select your layer and you go in your workspace where you can play with the order of the layers, share each of the layer with the social, different social web possibility, and of course download the layer in GIS format and share through the URL your workspace with other people in your organization or elsewhere. Of course, all the data, both the maps, geospatial data, and the risk data set are fully accessible, okay? It's, everything is built with using open source data and have a public license. It's a Creative Commons, so you can share, you can use. The next steps will be, after the launch of the platform was done in the COP28, we had a lot of very intensive phases of feedback between the CDRI teams and external person. So, but we have some more wishes that we want to apply to the future version of the platform. So we are the next steps are ongoing. As very last slide, is only to show you that everything is built using open source top of open source application, like these two kind of modules. But I don't want to take time on this and go straight to the thanks page. So thanks to all the people of the consortium, thanks to CDRI. So it's all. Thank you very much for your attention. And if you want to see something more, don't forget the screen outside the room.
Of the Global Infrastructure Risk Model and Resilience Index. Now we move on to the lunch break, and before that I'll just request the panelists for the session to just quickly gather for a group photograph and the presentation of certificates. Thank you.